So we're going to do exponent rules today. I think that you learned these in 8th grade. So I think this will be fairly easy. So we're just going to kind of go over this for you. On the exponent rules, on 6.1, the first 9 problems are evaluating expressions using exponents. So like if we look at problem number 3 here, the big thing, look at the difference between problem 3 and 4. Does anybody notice anything different? Avery. There's parentheses. So on problem number 4, the negative is also raised to the 4th power, but on problem number 3, the negative is not raised to the 4th power. So really you do 2 to the 4th power first. 2 to the 4th power means 2 times 2 times 2, and then there's really a negative out here beside of it. Okay, so it would be negative 6. 2 times 2 is 4, times 2 is 8, times 2 is 16. So the answer is negative 16.
And then homework number 4 would be.
So on this one, this means negative 2. All of it's to the 4th power, including the negative. So it's negative 2 times negative 2 times negative 2 times negative 2. So these 2 negatives make a positive 4, these 2 negatives make a positive 4, and 4 times 4 is still 16. So the difference is where the negative is. On the first one, the negative is not raised to the 4th power. On the second one, it is. So be careful on those. By the way, if you have an exponent that's an odd number, it won't matter. Why is that? Let's say it was negative 2 to the 3rd power.
It would just be 2 times 2 times 2.
Let's say it's negative 2 to the 3rd power.
It would be 2 times
Negative
2 times
1.
2. And then it's negative.
And it's still negative 8. But what about this? Negative 2 to the 3rd power.
It would be negative 8.
It still would be negative 8. Because 2 negatives make a positive, and then the 3rd negative makes a negative. So if it's to an odd power, it really doesn't matter where the negative is. It's going to be negative. It's the even powers that matter. Okay? All right, then you'll have problems like number 9 where we have to substitute some stuff before we can evaluate it. So we'll substitute on number 9. On number 9, we know that z is negative 3. And the biggest thing that you have to make sure that when you substitute is that you put this negative 3 in parentheses. Especially if it's negative, you want to put it in parentheses. So here's my original problem. And I'm going to substitute negative 3 in place of the z. That should be squared, not cubed. Sorry. That should be squared. So I'm going to do 5. And then where the z is, I'm going to substitute negative 3 and then square it.
Which would be.
So would that be like times?
Yes, but remember, we've done the order of operations quiz. What should I do first here?
The exponent.
The exponent. Yeah, remember that I need to follow the order of operations. Right, and there really isn't any parentheses. This is just indicating multiplication. So I need to do that exponent first. So negative 3 squared is 9, positive 9. Right?
Yeah.
And then 5 times 9 is 45. And then divided by 8. Will 8 go into 45 without being a decimal?
No.
No, so you can leave it as 45 over 8.
Oh, really?
Remember, Math Lab kind of likes you to do that.
Like 8 times. Avery and I were over here like thinking we typed it in wrong because we were like, it's still a decimal.
Okay, so you can do math enter on that, and it'll go back to it. All right, so the first 9 problems are just like figuring out the answer. Okay, so that's not really that bad. When we get to problem number 10, that's when we're going to start using our rules for exponents.
Wouldn't it be like
Okay.
5x times 3x?
So the first rule is the product rule. And the product rule says when you are multiplying expressions that have like bases, Now let's think about what like bases are. So the bases are the numbers or the variables that are multiplied together. Okay, so these x and x, those are the bases. So as long as those are alike, I can just add the exponents.
So 5 plus 3?
You're right. So this would be x to the 8th power would be the answer.
So I have a question.
Yes.
So what about if it was like x times z?
Then you can't do it.
So what would we do?
So let's say it was x to the 5th times z squared. You would just write it exactly the way it is. You can't do anything to it because those bases are not alike. They have to be like. Here's the other thing. If you don't, if you're not good at remembering these rules, let's think about what this means so that, because where it gets hard is whenever I start mixing all these rules together and you're like, okay, when am I supposed to add, when am I supposed to subtract? So x to the 5th means that there are 5 x's there, right? And then x to the 3rd means that there are 3 of them. So how many x's are there altogether? 8. Okay, so if you get confused, just write it all out and you just count. Okay? So on number 11 here, this is kind of what Leah was saying. I can only add the ones that are alike. So 11 plus 6, the y's would be to the 17th power. There are 17 y's there. And the z's, how many z's would there be?
7.
7. Good. Where did you get that extra one?
The Z already has a 1.
Yeah, if you don't see an exponent, put a 1 there. So let me write this bigger so you can see this. Like this z right here that you didn't see an exponent, if you don't see an exponent, there's a 1.
So just like how in x you always have to
Put a 1 in front of it. Yep, you can always put a 1 as the exponent also.
What if a line can be Z?
When I took Spanish, I always learned to put lines through z's so they don't look like 2's. So I have always done that since I was a freshman in high school.
It's so weird.
Okay?
It's like an E with a broken neck.
Okay, what's that?
Right there, next to your z. How did it become 7?
That's what I just said, Hayden. There were 6 here, and then there was 1 here. See that? This last z didn't have an exponent, and if you don't see 1, you need to put a 1. So there are 7 z's altogether. Okay? All right, let's look at the next one. This is still the product rule, so we're still going to be adding exponents.
Oh, look at all that writing.
Okay?
Why doesn't it just stick to the page above?
She's writing on top of the page. She's not writing on.
All right, here we go.
Because I got a snake in my boot.
Now, guys, again, you're taking your homework time. All right, so the numbers in front of the variables, you can go ahead and multiply those just like you normally do. So 2 times negative 5 is negative 10. And then all the z's are alike. So I can add the exponents. 10 plus 8 plus 2 is 20. So it's negative 10 z to the 20th.
Makes a lot of sense.
Negative 10
I have a
z.
question.
Yes, ma'am.
Will we have to put a comma between the 10 and z, or will it
No.
just stay the same?
Yeah, you don't want to put a comma between because it's negative 10 times whatever z is to the 20th power. We just don't know what z is, so we can't figure it out. Okay? All right, on number 17, they want us to find volume. Since this is the shape of a cube, volume is length times width times height. That's the formula for volume of any rectangular prism. Okay?
Cubes are rectangular prisms.
Wouldn't it be 8y to the h?
Length, width, and height.
Already has
So it's 2y squared times 2y squared times 2y squared. Right? The length, width, and height, they're all the same. So 2 times 2 times 2 is 8. Now, On the exponents though, we don't multiply them, we add them. So 2 plus 2 plus 2 is 6. So it's 8y to the 6th is the volume. Okay? So is everybody good on the product rule? So when you're multiplying, you do what to the exponents? Add. When you're multiplying, you add. Okay? Let's go on to the back side and we're going to do a different rule. All right. Okay, power rule. Everybody gets these two confused. Okay, the power rule says that when you raise a power to a power, you multiply the exponents. Okay, so take a look at this one. Number 19. It doesn't look like that there's an exponent on the p and the q, but there is. It's a 1 on both of them. I'm going to write this bigger. So I would write this like this. P to the first, q to the first, and all of that is to the 8th power. Okay? So I think of this as like distributing, right? Because there's a parentheses between my bases and my next exponent. So I just distribute that. So 1 times 8, this is p to the 8th. Q to the first to the 8th power is q to the 8th. So you don't add these exponents, you multiply them. Okay, because it's a power next to another power, an exponent next to another exponent.
So if it's like that, you just bring the 8 down for both of those.
Yeah, but what if these were 2s?
It would be p and q to 16.
16 and 16, right. So don't just bring the 8 down is what I'm saying. You really distribute your exponent that's on your base to the exponent that's outside the parentheses. Okay, and they don't have to be the same. Like this could be a 3. So that one would be 16 and that one would be 24. Okay, they don't have to be the same. All right, so this one here, we've got R, S, those both have a 1 on it to the 4th power. So don't let the fraction confuse you. You're still going to distribute both of those. So this is R to the 4th over S to the 4th.
Is that R over 5?
It's an S. Okay?
Maybe you should draw dashes through the s's too to make them not look like 5.
Maybe. All right?
I feel like she's done with you now, Norm.
22.
Oh, I know.
I'm trying to get done so that you guys have time with homework. So, those were both 1s. Who's asking me who? Those were both had a 1 on them, right? Remember, if we don't see an exponent, Leah, we're going to put a 1 there. So 1 times 4 for the top, and then 1 times 4 for the denominator. Oh, okay. All right. So down here. So go ahead and put 1s on all of those. So this is m to the 13th, p to the 13th, and then n to the 13th in the denominator. All of them are 13 because they had 1s.
Exponents are really easy.
Okay? Now the reason this, I know this seems simple right now, but when we do scientific notation next time, we're going to have to use these rules when we start multiplying things like a scientific notation by another scientific notation. So that's the reason we're doing these rules, because scientific notation is what we're going to do next time. All right? Okay, last rule is the quotient rule. Quotient means when we're dividing. Okay, so when we're dividing things with like bases, we subtract the exponents.
Knew it.
Okay, subtract the exponents. All right, so p to the 7th divided by p to the 5th is p to the 2nd power. Q to the 3rd divided by q to the 2nd is q to the 1st power. Now, I will tell you on Math Lab that they don't like you to put 1s. They just know, they understand that if you just put q, you mean q to the 1st. So it's not necessary to put the 1.
If you put q to the 1st, do you?
You subtract.
They'll probably tell you that it's not in the correct format. Okay, so here, Hayden, we're dividing, because remember that fraction bar right there means division. So anytime you divide something that has a like base, you subtract your exponents. Okay?
In what situation would you divide your exponents?
Never.
Okay, now remember that this has a 1 in front of it. So, guys, on the coefficients, that's the numbers that are in front of those exponents. Just do what you would normally do. What's 5 divided by 1?
5.
5. But these are exponents. So because I'm dividing, I subtract exponents. Don't divide exponents. So x to the 5th over x to the 4th is x to the 1st. Again, on Math Lab, they're not going to want you to put that 1. So just put 5x. Okay? There is a place on Echo for you to submit these notes. So that's an easy first grade for everybody. So submit your notes and then go to Math Lab and do this assignment, 6.1, which is due on Wednesday.
Wait.